Today I'm going to show you a quick and easy way to install a modern ground fault interrupter breaker. As you can see, in this kitchen, these two outlets here and here are not GFI outlets. They're close to a sink and they're in a kitchen, and current electric code requires that they be GFCI. They had a GFCI outlets in them, but the outlet died. And that's not uncommon with GFCI outlets because they're usually very cheaply manufactured nowadays. So we're going to install a breaker that's going to substitute for these outlets. Here is the panel that the breaker is in. Now we already have identified the breaker that is involved with that particular outlet. It's 26. We've also purchased the combo breaker that goes in there. The part I'm going to show you today that is a trick is how to identify which of the neutrals actually goes to that outlet. As you can see, I've removed the cover plate for the panel box. This is the breaker that we're going to be dealing with. Now, unlike a regular breaker, a combo breaker requires that the neutral going to the electrical outlet be wired in to there. Then this neutral goes to the actual neutral, and then the hot be wired into the normal place that a hot is wired into a breaker. The problem, of course, is that in most of the older breaker panel boxes, you have something like this, where all the neutrals come into one single bus bar. You don't necessarily know which neutral goes to the hot side. Now you can undo the wire from the breaker and chase it back to wherever it's coming in, but when you have a panel like this, which is all tightly with the wires all tightly packed into it, it's sometimes difficult to do that. So I'm going to show you another way to do that without having to chase the wire back. And also we'll learn a little bit about electrical theory. The thing we need to do is we need to install a load on the circuit in question. I'm using a space heater. It's a fairly high load. You don't need to use a high load. You can use an electric light bulb if you want, but it is easier to find the circuit, the neutral, with a high load. Turn that on, let it run, then we'll go back to the panel. What you need to do is put a tool called a clamp-on ammeter onto the load. Now in this case, we can see that the load is 12.3538 amps that the meter is drawing. And as you can kind of see, I had to put the amp meter on the wire after it kind of looped around the back of that breaker there because it was so tight in there. But that's the first thing you need to do, is find out what the total draw of the load is on the black wire that's going to the outlet that you want to put GFI on. The next thing we start doing is putting that same clamp-on ammeter on each of the neutral wires that we think are good candidates that could be drawing that power. As you can see, this particular one is only drawing 0.7 amps, so clearly it is not the circuit that heater is connected to. So we're going to continue trying different ones, and it's okay if you put the clamp-on ammeter over multiple white neutrals, because you may have clearance issues with getting the clamp-on ammeter, depending on how big it is, into the box. But sooner or later, you're going to find the neutral, and it's going to have the same draw on it that the hot wire has. The other thing we can do to make things even safer before messing around so much in the panel is turn everything else off in the panel. Now this particular panel is what's known as a split bus panel. So it has no master breaker. Instead, the top 6 breakers have to be turned on for the panel to be completely depowered. Now we are going to need to turn on the one breaker that feeds the other. In this panel, the main breaker that feeds the rest of the circuits down below is up on the left. So we'll leave that one on, and we'll leave the circuit on that we are looking for the neutral for while we probe around in here looking for the neutral that's going to that circuit. For example, this one here is not in use. As you see, there's only 0.24 amps on there. That's what we call leakage current, and it's common when you're using a clamp-on ammeter to measure stray currents. Okay, it looks like we found our cable. Now, because of the tightness of the clamp-on of the wires in there, I had to put the clamp-on ammeter around several neutrals. But one of those neutrals is drawing enough power for that heater. So it's just a matter of process of elimination of figuring out which of the neutrals is likely going to be involved in that circuit. And so we know that this neutral is not it because that's already going to that breaker, and we know that that neutral is not it either. So it's actually going to be either that one, or that one. Okay, so this is definitely not it because it's not drawing any power at all. So it's one of those other two. This one is not it either. Once more, zero current flow. So it's got to be that last one. And there we have it, success. That's the neutral that is involved in that circuit, which is on, and is feeding our space heater upstairs. So all we have to do to verify that, turn that off. We can see there's no current flow, and we can go upstairs for a further test and turn off the space heater and then turn back this on and see if there's current flow. Okay, the space heater is turned off. The breaker is still on. That's the only breaker in the panel that's on. And the current meter is showing no significant current. So that is definitely our neutral. And we can test that further by powering off the breaker, disconnecting the neutral, powering the breaker back on, and seeing if power comes out of the outlet. But I'm not going to bother with that. I'm going to instead just install the breaker. As you can see, I've gotten the breaker removed and the hot and neutral wire isolated for that circuit. Of course, one of the problems is with these tightly packed panels is that the neutral isn't going to reach all the way up to where the breaker space is. So instead what I'm going to do is I'm going to relocate this breaker and that breaker up one, and of course I'll have to modify the legend, and then I'll put the new breaker on the bottom so everything will reach. Okay, now this is seated in there all the way. You can't see the clips that easily, but I can, and they are fully engaged. Breaker, it's a square D breaker, but it's a little bit off from the other ones, so we may have some interference in the panel. We'll have to see when the cover goes back on. Make sure that all the other breakers are completely seated down, and make sure, of course, when you're moving breakers around in a panel that you make sure that any open spaces are covered so that they can't be people can't stick their fingers in. Now it's time to connect the neutral wire. So here we've got the neutral wire connected. Another thing that's important to do when you have the panel depowered is to basically go to each screw in the panel and make sure it's tightened down on the conductors. Sometimes when you're wiggling things around in there, you can loosen up screws. I've already done that to this panel, and of course do the same thing to the hot conductors that you can reach. I've also already checked this with the cold conductor, the neutral conductor that's in the back of the breaker back there. Just make sure that everything is tight and that none of the wiggling around that you've done in the panel has loosened any wires up. So, now that we're done, the last thing to do is to power the panel up. Now, as you probably noticed, I replaced one of the breakers, the breaker that went to the range, with a whole house surge protector. Alright, power is back up. Now it's just a matter of replacing the panel, their cover plate. Okay, so the panel cover is back on, and we've updated the legend. And a few words I'm going to say about this particular setup. For starters, this is a split bus panel, and they look like a sub panel, but they're not. These are main panels, and they were common before 1981. In 1981 they were made illegal to use for main panels without having a master breaker in front of them. These follow a rule called the 6th row or less rule, which basically means that you can turn off up to 6 breakers to have the entire panel off. And that is normally the top 6 breakers. Of course, in this case, one of those breakers has been removed and replaced with a whole house surge protector, because the electric range that was being previously fed off of that circuit was replaced with a gas range. And so it doesn't need to be, the circuit doesn't need to be live anymore. The other thing you'll notice on this is that the breaker that I installed with the purple tab is actually a more modern combination breaker. It's dual function CFI and GFCI, arc fault and ground fault protection. And you're going to probably read a lot of nonsense in the various forums about how you want to not use GFCI break outlets if you can help it, and so forth and so forth. But the reality is that the way the electric code is going is pretty much all of new panels are going to require these combo breakers. So we might as well, use them in cases where you would need to put a GFCI. They're definitely safer than a GFCI, and The newer models have been redesigned so that their trip current is not as high as the old models. So if you have leakages and things like that, which might cause a false trip, they don't happen so much anymore. And in any case, if you have a false trip on a GFCI circuit, you really need to troubleshoot it and find out what's causing it and get rid of whatever is causing it, rather than just trying to mask it by putting a regular breaker in there and getting rid of the GFCI protection. Anyways, some people might say to replace a panel like this, but you know, that's one of those decisions that you have to make. It's not required by code to do it, but and certainly if you have the funds to do it, it's safer. But it's pretty safe to. It's certainly safer to replace individual breakers with more modern upgraded breakers than to not do anything about the panel at all. So, all right, that's the presentation. Thanks very much for watching. Hope it helps.